Oh my God, Steve.
Good morning, Mark.
Hey, long time no see.
I'm not traveling for a change.
Yeah, I was in your presentation to my employer. It's very slick.
Oh, the one we did recently. Yeah,
Yeah, it's perhaps related to the topic of today's conversation. Oh, let's see. It's good. There is a new SIG being stood up for specifically regulatory and standards. Um, I want to talk to them about perhaps shrinking our charter and pushing some of the stuff that's in our charter over to them. I want to focus on threat modeling effectively and technical controls.
yeah. I need to I need to relook at all the SIGs that are going on and figure out where the best use of my time is at this point.
Yeah. Right.
But that's a project for another week.
Yeah. I mean, once we are done with the inferencing training and reverse proxies, there may be less for us to do here because there are only so many distinct
Yep.
cases. So I do not mind sunsetting this group at the end of this year if we achieve all our goals or just to convene as needed. But yeah, AI and continuous computing is still such a big beast that's probably for the next few months can keep us busy. So,
Hi.
hey, Nikolai, it's been a
Nikolai.
while.
Yeah, it's been
Welcome.
a while. I'm trying to keep up, but quite often there are other things, other
I
meetings at this
oh,
time.
don't I know that?
Yeah. But
Okay.
I'm really I admire how you managed to be so persistent and keep up the pace. So that's great to know that, meetings
I
will most likely
have
happen.
a bank employee's temperament. I can basically persist through bureaucracy, through neglect.
I think I
You
don't, which is
thrive in
probably why I
adversity.
keep leaving big companies and going to startups over and over again.
Yeah, it's surprising how much actually the personality and temperament affects the type of workplaces we choose.
Yeah, yeah, I've always ever worked for really big companies and really big bureaucracies, and I'm somehow managed to. But anyway, thanks for the compliment. So let's jump in. I'm gonna put up the link to meeting minutes as usual. So I already put your names down, so I hope you don't care.
Already been voluntold for tasks.
Yeah. So I forget which company you work for. That I didn't put that down.
Canary bit,
Oh, Canary Bit, correct.
Canary bit, yeah.
All right.
By the way, was it? I remember. It might be a bit off topic. I remember you wrote the email about having also maybe in this group or another about like working with regulatory agencies.
Mhm.
How did that evolve?
Not well.
Not well.
So
Okay.
a new SIG is being stood up. It's actually co-chaired by a colleague of mine, Michael Guzman, from the firm.
Mhm.
From the firm. Yeah.
The firm, yeah, yeah.
Well, that's literally what we call it inside. It's I don't even know if it's ironic anymore. But
Yeah.
anyway, so yeah, it's focused on regulations and standards. So one of the things I want to do is I want to meet with them and basically cut off a part of our charter and throw it over the wall to them. I mentioned
Mhm.
this to Steve. All right. So yeah, if you're interested in speaking with regulators, for that I do not have the temperament.
Okay. No, because like, well, the thing is like I thought we might have a useful let's say experience since we had it let's say a regulatory sandbox here in Sweden with the Swedish data protection regulator. Uh,
Hmm.
and we had that exercise. We're waiting for the report later this year.
Yeah.
And of course, probably the experiences will differ between Europe and the US, but still might be good to have these different
Yeah.
perspectives.
Right. So the way I see this in this group, we will keep if you remember in our charter, it basically outlines a infinite loop you're in. You
Mm.
set the targets, and then you measure yourself against the targets, and you have to have levers. You need to be able to exercise the levers, measure progress, obtain all the evidence. That's the technical side of it. We'll keep that. As far as talking to the 100 or so regulators that are out there, it's over 100 actually. I'm perfectly happy having somebody else do that.
Makes sense.
And the thing is, I personally have libertarian tendencies, so like it makes my blood boil. What it is that these people want us to do, but that has nothing to do with technical means of achieving,
Yes.
someone's assurance that whatever policy they have in place
Mm.
is being adhered to. So we'll keep that here. We'll let
And I
them.
think the fact that you're handing off to Michael is going to work really well to make sure it's a clean handoff and integrates well with what we're doing.
Yeah, absolutely. It's also very, very easy to hand off a clean Petri dish. So, okay, enough humor. All right, so we're gonna look today into the draft that is currently being authored. So this is the AI/ML inference. So please open this doc. And yeah, okay. And it's so just to level set and bring your context window back. Let me also share my screen. I realize it didn't show what I'm doing. Okie dokie. So yeah, it is this paper from Anthropic that does a really good job of explaining what sort of the problem domain of computational computing. So let me see if maybe I can even open it in my screen that I'm sharing with you. Like uh, I do not know if giving them a nod, as it were, uh, is sufficient to avoid like flat out copyright violations. So like here, I basically say we're liberally borrowing from this paper, but this is the paper.
All right.
It's really, yeah. Why it's so slow, but anyway, if you read the paper, this is not like a straight copy and paste, but so much of it, uh, is really good content
Mhm.
that I effectively ended up borrowing it. But we will also see, perhaps what we can do today, because it's been a while since we last spoke, is if I could have you take a minute and go through the first 3 pages of this text,
Okay.
right? Don't even look at my screen, just open it on your own and take a look at the comments that I added and take a look at, please add your own comments here so we can start understanding sort of kind of what are the next steps, because I'm pretty much done and I have to re-add a couple of things with the problem section. And then what I want to switch into next, so let's just give us maybe 10 minutes. It's not a whole lot of content. Is I want to switch into, can we start looking at the things in the problem section and the forces is what makes solving these problems difficult, if you remember, right? So we'll do that. And then we'll see what content we can author and what other topics for discussion we can have. All right, so let's just go do that for maybe 10 minutes.
Okay.
Having read this, I see it's I think the containment part is the most interesting and difficult here.
Yes,
And it's I don't have an answer, and I've been thinking about this for a couple of years. And every
right.
time I have an answer and talk to other people, then they manage to break it or show me that my answer is wrong. So I don't know. I'm actually curious how what Anthropic writes about it, but it's an extremely difficult problem.
Well, that's what I started doing was I moved over from your document, Mark, to the Anthropic document, and I'm
Yeah.
reading through it at the moment. Um, and it certainly seems to be focused on how does the model owner protect their models and weights,
Yep.
more than it's focused on the data owner protecting their data. And certainly in the LLM use case, um, which includes MCP and A to A, uh, people are giving vast quantities of data to the models.
Yes.
So, in some ways, the focus needs to be on what internal parts of that data are sensitive as opposed to all the data. You can't have the chat dot do its job without giving it something to work on in the first place.
Yes.
Yeah,
Well,
and then
so we're not quite in the solutioning phase just yet, right? So what I want to do is I want to make sure that we have an agreement on the problem space, right? So this is the first part. So here we're not talking about the why is this difficult, let alone how to solve it. We'll get to that later in the document. But let's just agree that this is the problem domain. And then once we get into forces, that's exactly where I will say, it, a force may be that, you're feeding vast amount, like not the final version, but you're feeding vast amount of data into the model. You're getting responses out of the model. It may in fact be difficult to protect a model running in this manner from reverse engineering of some sort.
Yeah, I
Maybe, I
mean,
don't know. Like we can say that in the forces section. Then finally we get into solutions and say, well, this is how we recommend you go about solving this.
yeah. So when we look at forces, when I've described this problem in the past, you've got a triangle, right? You got the service provider, you've got the model owner, you've got the data owner.
Yeah.
The model owner is wanting to protect their model from both the service provider as well as protect it from the data owner.
Correct.
The way this often gets handled is somebody does inference as a service. So they stand up a hosted system and they have a relationship with the service provider, or they provide their own services and their own hosted systems in Equinox or something.
Yeah.
And they run their models there and they ask people to submit data into the system. So
Yeah.
one force is that line. It's how does the model owner protect themselves from the service provider? There are data owners who aren't happy with that model.
Mhm.
And so they'll say, well, I want to run your model on-prem. And so then the data owner becomes the service provider at that point, or maybe they use a cloud, and the data owner takes possession of the models.
Yeah.
In which case, the relationship is the model owner is trying to protect themselves from the data owner. So I think each of those triangles or each segment of that triangle
Yeah.
has a set of concerns.
Yeah.
And it's typically solved one of two ways, either by the data owner owning the service provider or the model owner owning the service provider. And then either the model goes to the data owner or the data goes to the model owner. And there's risk management that has to exist for each one of those kind of submodels.
Well, so hold on a second. Let me understand this a little bit better. So there's clearly a case that you seem to be alluding to where, let's just say, there is a SaaS vendor, right? This happens
Yep.
outside of AI ML as well.
Anthropic is hosting Claude.
Well, or even like just in case, like, just take Wiz, right? Like Wiz analyzes your security configuration.
Yep.
You give them your data.
Same thing. They've got their models.
They got their models, they got their solution. You give them their data. If your data is super sensitive, like if we have a security vulnerability configuration something in our AWS environment that is weak, and we you scan all of that stuff and hand it to them. If they have a breach and will have a vulnerability, then that vulnerability effectively becomes public. Now it gets exploited.
Yep.
So that's a risk. Alternatively, and this is, I'm kind of repeating back to you what I just said, what I heard you say. If they give their IP to us, then the chances of our security vulnerabilities leaking is diminished because we trust our perimeter. But their IP may leak, so they don't trust us, right? And that part I get, and we can talk about that. But there is a third case where I'm a vendor of some sort, and there is a customer of some sort, and we both agree on a certain service provider, right? It
They
could
call that the
be
escrow
cloud or
model.
could be edge, and we basically say, well, the model will go there, and the data will go there, but it's neither of our entities.
Yep. I call that the escrow model or the clean room model.
Right. So, do you feel we should address them separately or handle everything as a type of escrow?
Well, I think all three, I think in your forces, um, uh, you arrive at those three different configurations by starting with the model and the data owner, right?
Mm-hmm.
So if the data owner wins the argument, if you will, my data is more important than your model. There's a lot of businesses that have AI inference systems that agree to ship their system on-prem.
Mm-hmm.
The flip case is there's a ton of inference systems that host their applications in the web and say, like it or lump it, here's our service, and you choose the risks to either send your data or not, right? So
Right.
I think those are forces where either the model owner or the data owner kind of wins the ownership game.
Yeah.
Um,
Okay.
the
So,
escrow model is a third scenario,
right.
right? I'm buying a house, which is literally where most people associate escrow, and there's a
Right,
third
right, right.
party that is trusted by both parties, the
Yeah.
data owner and the model owner, right? So you introduce a third party to the game, and you say, now you have a lawyer, and the lawyer mitigates or monitors the transaction. Blockchain lives in the escrow world. We all agree on the terms of the blockchain and that our transactions can go in the ledger, and that public ledger performs that same role of the escrow. But these are the three forces, as you point them out. It's those three, depending on which one becomes the dominant one.
Okay.
Confidential computing can change the equation, right? I'm working with a company that does customer service work. And they have a model that they've tuned, mostly working on Olama as the engine, and they run it hosted. And GE Medical just split out and wanted to run the system on-prem.
Yeah.
And they're having an argument on whether they're going to ship the product on-prem and what controls do they want to put on that product before they ship it on-prem. Now, with a company like GE Medical, you can probably trust they're not going to reverse engineer it and run away with it and do it. But it's back to your forces. They're having that discussion right now, and we're in the middle of the discussion talking about should the inference engine run on-prem, and the models are stored in an encrypted state and they only load into confidential compute. And so when you boot up the system, it runs in an enclave. You can verify it's in an enclave and that GE Medical doesn't have access to it, and pull the data in.
Okay. So, I sort of couple of thoughts. One thought I had when I was hearing you speak was that I would like to at least try And first focus on what you call the escrow model, where there are three
Yep.
independent entities, and they all do their own part correctly. And effectively, we build the same governance matrix as we've done in other.
I think that's the right way to do it because confidential computing will essentially be a subcase of the escrow model where you're using technology, confidential computing, as the escrow agent that establishes mutual trust.
Okay. So, and then what I would like to see is once we do that, because I mean, inarguably we will have to solve that case one way or another. But
Mhm.
once we do that, I would start with that one and then see if it reduces to the other two when either the data owner or the model owner is the CSP, is the model host. Okay. Uh, Now, with that aside, like if somehow it's irreducible, then I think we should make that a separate force and basically say, turns out that unless you have an independently verifiable CSP, you will need to have these additional considerations. So I would start with a fully like generalized situation and then see if it reduces. The second part I wanted to say is I heard you a little bit misunderstand what forces are. So, for instance, forces are not configurations, right? In this case, whether you have a CSP or not, that's not a force in its own right, unless you can show that, folding a CSP into one or the other is a problem. What is an example of something that I would put in the forces section is, for instance, this. Many institutions collaborate on a joint, uh, data processing of some sort, and they all live in some cloud. And so institution A and institution B, uh, they're separate data owners. And the thing is that what they cannot do is they do not trust their own, like each other's key management solutions either. And right, and because the trust execution environment needs to obtain its keys from the key store, it may be that customer A has its own key store, customer B has its own key store. And we basically have to say one of the forces is that, whoever, like irrespective of where you run the thing confidentially, you may still need to keep control of your own keys separate from whoever, the other parties keep their keys in. So key management, the difficulty of disjointed key management is a force in its own right. I would put that like as an example of something I keep in there.
I definitely jumped quickly from forces to solutions. I have a presentation I give on a related topic here where I start out the conversation by saying, I'm an AI company. I've got these really smart AI engineers that have built these models. You've got data. Can I have your data? And the answer to that question is no. And one of the forces involved is there's a joint business result
Hmm.
that people want. From my old life in the fraud prevention world,
Yeah.
what would happen is my company, 41st Parameter Experian, had models, and banks like JP or Bank of America or Citi or anybody else would have data.
Yeah.
And we have a joint combined solution that we want to provide. There's a business goal for the combined entities
Hmm.
um, that are going to get us over that no, that will get us over that hurdle. And but the forces, what are the concerns of the bank versus what are the concerns of the AI company?
Yeah.
Those never go away, right? It's just the business needs get to the point where you negotiate a solution that you say is good enough to solve the problem.
Right.
I wanted to add a thing. The focus on AI models and I don't know if you mentioned LLMs anywhere in particular adds further complexity because they memorize things and there are more and more results where you can recover data almost verbatim from the model, which makes this slightly different. And I wonder if we need to make some sort of distinction between models that, yeah, exactly, ephemeral. Yeah, well, persistence. I don't know, but what I mean is that by training the model itself, the data becomes part of the model. And there was this paper that I wanted to share. It's very fresh about.
Actually, I think you're onto something here. So I think this paper, the Anthropic paper, implicitly treats the model as a static construct, as in there is a, and by the way, we're going to separately write the training pattern,
Okay.
right? That basically says, well, if you train the model, we haven't gotten to it yet, right? But what I'm hearing you say, and that's what I'm saying, you may be onto something, is there may be a hybrid where, okay, you train the model, you did a bunch of things, you did everything right, awesome. Now you went and deployed it, and now you're using it. But
Right.
as you're using it, it's learning. And I think increasingly
Exactly.
we're going to get into the model, the part where the model evolves during use.
Exactly. And because otherwise you have like concept drift and other things.
Absolutely. And I guess what I am inclined to say for now, because there is plenty to do just with the static model, is I would mention here that, for now, for version 1 of this document, we will treat the model as a static construct, irrespective
Yes.
of this
Good.
persistent caching stuff. And then we'll take it up as part of the confidential inferencing pattern, right?
Yeah.
Figure that out separately. So under inferencing, you're not using it yet. You may be testing it, but you are, throwing stuff. And then after we do both in isolation, hopefully we'll have understood enough about the combined thing that we can basically say, what happens if it's training as you're using it?
Yeah, I
Yes,
think it's a
I'm
good plan.
afraid that
Yeah.
if we handle this up front, it's going to explode the complexity to a point we
Uh,
can't even handle it.
yeah, it's going to be too much context.
But
I agree. This is a good way to
okay, so let
divide
me,
it.
to that, let's make sure that we capture this for at least for now.
It is a really good point. The terms have all changed in the post LLM world in terms of what people are using. Um, uh, Back before LLMs, the big split was between recognition and generative workloads, because if it's not learning, it's not really ML. It's just an algorithm, and inference is usually just a static algorithm that's been trained. Having a feedback loop on it that learns, I think, is an important element of it. But if I train a network to recognize social security numbers, those social security numbers are in fact embedded in the weights of that model. They're there, the things that it was trained on. But if you're just doing a recognition problem, it's almost impossible to back those learned values out. When you're doing a generative solution, you've got the other problem. When you ask the LLM, could you give me an example social security number? And it produces something that's 3-2-4. Is that a real social security number? Is that a social security number it was trained on? Is that right? Where did that number come from? Becomes a really important question that we probably don't want to try to address other than arm wave it here early on, that there's memory and there's learning and there's additional forces that they then imply for both the data owner in terms of concerns, what's going to happen to my data, and the model owner, how does my model become more valuable?
Yeah. And also
Uh,
all the stuff with like, how do I make it forget me if I insist? Like all of that goes in there.
Yeah.
yeah, I shared a link to an archive paper that is like that I saw a couple of days ago, where researchers from Stanford and other places managed to recover large pieces, almost like 98% of Harry Potter from a production LLM that is available online. So there are more and more results that show that you can recover a lot of text or a lot of data from production models.
Yeah. Yeah.
Yeah.
I mean, this is such a common thing even in human. Like if somebody works for a company and then they'll leave and they work for another company, it's impossible to prevent them from using what they learned in the previous job. Like we're stateful creatures.
That back in the old days, RC4 is a really simple algorithm. This is like 4 lines of C code. And it was protected
Oh,
by
it was munitions. Yes.
yeah, it was protected as munitions and under NDAs, but pretty much any developer that ever saw it because they had to code it, that was brought into the tent to go implement it, would be able to reproduce it from memory pretty quickly.
Yeah.
I think one of the challenges we're going to have with this document is LLMs operate on a scale that's very different than what people were doing previously, even compared to image recognition.
Yeah.
And it then introduces a whole set of new problems just in its own right, above and beyond generic inferencing use cases. Your example of
Right.
Wiz, they're operating on an entirely different scale, like 2 orders, 3 orders of magnitude less than Anthropic is.
Right. Okay, so we'll note that for the future, and for now, we're going to scope it back to the model is a static construct, understanding that it isn't. Okay,
And we
such
may
that
be able to just address that as it's a concern of the data owner, right? It's a force.
that may very well be. Let me add that as well. Uh, why is it so slow? I just typed a bunch of stuff. It's just not reflecting. Hello? Oh, there we go. All right. We will have to circle back on that anyway, Steve, because it explodes the scope.
Yep.
Yeah, and I'm just, I really like to eat the elephant one bite at a time.
I'm not going to argue with that.
Okay. All right. So have you finished reviewing the text as written? Can we now proceed?
Yes.
Okay. So let's start sort of drafting the forces. So effectively, what I'm trying to do here, and I started writing things, but so this again to remind you, the structure of the document is, the problem relates to the context. There is nothing about the problem that's not sort of covered in the context. Similarly, once you get to forces, you don't introduce additional problems. If you have additional problems, you need to put them in the problem section, such that in the forces section, you speak specifically to everything that's in the problem section, nothing else. But hopefully everything in the problem section is reflected in the forces section. Otherwise, why bother? And then once we get to solution restricts itself just to the forces and nothing else, right? So what I've done here is much like we had keeping the model conversation confidential, keeping the data confidential, right? So, all right. So what do we have here? We have keeping the data confidential, and then the second line I call keeping the model trustworthy. So let me change that. Not because it's not just the confidentiality of it. Like, okay, keeping model trustworthy. But again, so to walk you again through the structure. Under the keeping data confidential, there is end-to-end data confidentiality, there is privacy, authenticity, and containment. Similarly here, end-to-end confidentiality, privately, authenticity, and containment. And what I'm hoping to do is effectively kind of a split screen this. When we talk about the end-to-end data confidentiality requirement, right? So whatever this paragraph states should have a forces section, why uh, yeah, why am I saying? Yeah. So why is this difficult specifically? We're not further elaborating on the problem, right? So so let's reread this for a second so we can properly author that section. So we are Steve, are you keeping change tracking on?
Oh, I should have. Sorry.
Yeah, okay. All right. So yeah, I'm guilty of that sometimes myself, actually more than sometimes. All right, so data assets, which by the way, I have made a comment. Data assets is not a term that we've defined, right? Like we talked about model inputs and outputs, right? So I don't know, maybe we should say that, but there is a comment to that effect. They must be protected throughout their lifetime, which means at rest and in transit as well as in use. These keys used to protect data at rest and transit are securely provisioned and kept inside the T, where they're protected alongside all other in-use data. So inside the T today, we don't have separate areas where the keys are protected versus the rest of the data is protected. So I'm kind of just going with that. All right, so uh, okay, so here, just read over this. Achieving data confidentiality requires properly managing the workloads. And we already have existing art. We're basically saying this is how you govern the workload and the workload upgrades. So these are existing patterns. So, you need to code them securely. And then talking about securely managing of keys. Any actor interested in confidentiality of the data must independently ensure the security of their key management. And that's what I was talking to earlier, Steve, where if I'm interacting with a system and the system requires key management, I need to make sure that the keys that, I trust the key management of the keys involved. And that's a consideration. That is something that designer of the system must be aware of. Like, for instance, you do not hand out keys to every user of the system because
Right.
that would negate the the whole point, right?
That's right.
Any actor in their data must independently ensure their security for their key management. I don't know if this is a strong enough statement. So we can talk about that. So effectively, there are two parties to any interaction, and the parties both need to agree on the key management of that pairwise interaction. So I don't know
That's
how
right.
to say that without confusing the reader. But I do say here, for example, a system with multiple actors and keys corresponding to these actors may include multiple independent key stores, each with its own key access control policies, operated and managed by individual actor.
Yeah, I mean, there's functionally there's two different things. There's what protocol do you and I agree on, and then you're responsible for managing your keys. I'm responsible for managing my keys.
Yeah. And then the question is anything else. So if you look at this section, this paragraph, and compare and contrast with specifically this, right? Should
Yep.
something else be said? And again, I'm perfectly happy to effectively outsource to a document already written elsewhere, so I don't have to repeat everything. So I'm already saying, look, you need to, if you want your data confidential, you need to make sure that the workload is properly governed, the workload upgrades are properly governed. I don't want to say that the verifier is properly governed because that's sort of implied in all confidential computing.
Yep.
Right? And then I separately say, look, you have multiple pairwise relationships that need to have their own keys. And then we can, again, this is not solutioning. We're simply saying, you got to do these things in order to ensure end-to-end data confidentiality. Well, under the solution section, we may say things about, well, and this is how you do that.
In some ways, I feel like I just need to write some stuff, and then we can split it into the three buckets of uh, problems, forces, and solutions.
Now, however is most efficient for you. But if you think that this is a complete statement, again, not solutioning, simply saying, these are the kinds of things you ought to do, then we can switch to privacy, which to me is a much bigger and hairier thing because it's a little bit less well defined. Like what makes privacy hard? And let's again see what the privacy says here. Under privacy, in addition to confidentiality. Sometimes the data may be additionally subject for privacy safeguards. And here I have a question. How can adherence to privacy safeguards be achieved and proven to an auditor? And again, we don't have to say that here because this is just a requirement. This is a problem,
Yep.
right? But under forces, right, I would like to, in fact, I'm almost thinking that I should take this content, like copy this and put it under forces because this what makes it difficult is not a right. So this is where this comment belongs. Like, and like again, if you have
Do we need
experience
to
with
break it into
privacy,
pieces? Nikolai had the concern, how about the right to forget? How does that work in a trained model? Does the model owner even have the ability to do that? And is that something that the model owner ultimately has to state what capabilities they have, and the data owner gets to choose whether they want to play the game or not?
Actually, yeah, I like that thought. Basically, you might accept a degradation of the service in exchange for the capability to exclude certain data from the model, so retraining the model and so on. I think that's a good idea.
okay, so feel free to author content here because this is an area where I have perhaps the least amount of experience. And
The problem with privacy is that it's a legal term ultimately, and then it's like you have this very broad spectrum of definitions. Difficult because it's not a technical term per se.
Yeah, but it doesn't matter ultimately how broad the definition is up in the problem side. We just throw out what the problems are. Right. That's why I use that really simple example when I talk to customers. Can I have your data? No. The answer to that question is always no. Nobody really wants to give up their data. This isn't 2000 anymore. Everybody knows that data is going to get used for various purposes. But no, in a business context, always means let's negotiate. And so, what are the problems you have? What are the concerns you have? Well, we should just list these concerns. Why don't you want to share your data?
But yeah, let's capture all of these things because again, we can have focused discussions on all of these, and also we can fire up a background thread, and when we reconvene in a couple of weeks, we can talk, or maybe have a conversation with your favorite LLM to help answer some of these questions. Right now, all I want to do is I want to generate things because as I always say, you cannot edit a blank page. So let's throw some stuff on the page and come back to it. I would even put, meeting laws and regulations, even like identifying. That's one of the forces.
Yep.
Which regulations apply? Like before you can meet them. Like, can you do it automatically? Can you do it asymptotically? But if I'm a and here's another thing, if I'm a CSP and I'm asked to deploy a model, I don't even understand how it works in terms of the shared responsibility model. Who is responsible for I like maybe under EU it's a different thing, but say I'm operating a cloud in the European Union, and then somebody goes deploys a model in my cloud, and that is a privacy disaster. Who's on the hook for that?
Yeah, I'm trying to think where to put this. We have a tool in our product that recognizes PII, so you can filter it out before it moves on to the next step, for example. before it transitions into and out of. So then you can prevent it from ever going to a model because you're going to mask it before it gets there and do that all automatically.
So I'm just, again, writing down this.
Yep.
Because again, I don't, this is where I depend on crowdsourcing the answers. I don't understand that. Is that under data confidentiality, Steve?
I'm really, I was saying, the problem on my mind at the moment is governments requesting subpoenaing keys from CSPs.
Oh, yeah. Right. Interesting.
Which is a hot topic at the moment.
Right. Yeah, and that's going to be an increasingly so, because especially with more and more what I call extrajudicious overreach,
Yep.
like governments just basically, want to intercept communications.
Our customers are regulated and paranoid, and we're getting plenty of requests on the sovereignty side of things.
Yeah.
I don't know if any of these are right or wrong, or I got them in the right place. Just
That's okay.
popping in my head. I'm putting them down.
We'll sort them later, but this is a good place to sort of capture it for now.
Suppose all those should have been up in problems, but we'll move
Well,
them.
again, we can reshuffle things later, but yeah, problems say nothing about whether it's easy or hard, and forces say nothing about how it can be solved.
I use a definition whenever I have an engineer in front of a customer, and I say, when an engineer says a problem is easy, that doesn't mean it's short. It just means they know the steps to get from point A to B. When an engineer says a problem is hard, that doesn't mean it's long. It just means they don't know the path to get from A to B.
Right. Yeah, it's the amount of intellectual investment in getting there, not the number of steps.
Yep.
So unloading a truckload of coal is easy.
That's right. Good example.
Okay. So the homework for the next couple of weeks before we meet again is to try and provide some answers to these questions, and then attempt to fill in the rest of the keeping the model trustworthy, basically. All of that needs to be filled in. None of it is here just yet. And then hopefully next week we will have a better handle on the problem space through forces, and then we can switch over to the solutions section.
Sounds good.
All right. With that, I'm going to wrap this up for today. Steve, thank you for your participation. Sakul, you're new. I hope you enjoyed your time here. And
all right.
yeah, I'll see you later.
Sounds good. Thank you, Mike.
All right. Thanks. Bye-bye.